In this video, I'm going to show you how to solve a direct variation problem. When we have a direct variation problem, it's important to know how you come up with your equation. So for direct variation is normally written as y equals k, our constant, times our x variable. So in our example here, we don't see k in here. So if I were to write this, I would say y varies. So I would start off with my y. Y varies directly, which means I'm going to be multiplying the constant by the x term. But I need to solve for k because I need two x's and two y's in my answer, or in my equation. So I'm going to divide everything by x. And now I have the constant equals y divided by x. And so if I have my constant divided by x, I'm now going to have y1 over x1 equals y2 over x2. And we can treat this as y1, x1, y2, x2. So that's what we're going to be finding. So all I'm going to do is just plug in my numbers into my formula. So my y1 is -9 divided by my x1, which is 6. And this has to equal y2, which is, I don't know, so I'm going to find my y, when x is -7. So when I have a fraction equaling a fraction, they have to equal each other. So I can use the formula, or not the formula, the method of cross multiplication and division. So I'm going to cross multiply -9 times -7, which is 63, equals cross multiply the other direction, 6y. Now to get y by itself, I'm going to divide everything by 6. And I have 63 divided by 6, which is going to give me 10.5. Or you can rewrite that by dividing 63/6 by 3/3, and you could get a fraction as well, but 10.5 would work. Now with this, it's important that you make two equations, or two ratios that are equal to k. And that's why you have the y over x, and that's why I came up with this formula of y1 divided by x1 equals y2 divided by x2, because they both equal the constant. Next example is inverse variation. Inverse variation is very similar to direct variation, except for when y varies inversely, we're going to say y varies inversely, which means I'm going to take my constant and I'm going to divide it by my x term. So it's going to be y equals k divided by x. Now I can rewrite this formula just like I rewrote the direct variation by solving for the constant. So to do that, I'm just going to take my k, or my x, to get rid of my denominator. I'm going to multiply it by x on both sides. So now I have the constant equaling xy. And if I have two equations like that, they both equal k, I'm going to have a formula of x1, y1 equals x2, y2. So now if I look at my example, if y varies inversely as x, and x1 is -5 and y1 is -1.1, find y2 when x2 is 2. So I'm going to use this formula down here that I have, and I'm going to plug in my numbers. So x1 is -5, my y1 is a -1.1, equaling my y2 I don't know, but my x2 is a 2, and I'm just going to put a y because I have to solve for y. Now my next step would be just simplify both sides. Negative 5 times negative 1.1 is a positive 5.5 equaling 2y. Now to get y by itself, I'm going to divide everything by 2. And 5.5 divided by 2 is going to give us a y value of 2.75. Now if you were to put 2.75 back in for y, 2 times 2.75 is 5.5. So that is a quick way you can verify your answer. Next example is joint variation. Joint variation means you're going to have more than 2 variables involved that you're multiplying by the constant. So normally we would have y equals the constant times x times z. But you'll notice in my example below, I don't have any x, y's, or z's. So I'm going to use the formula a equals the constant, because it says a varies jointly. So jointly means I'm multiplying b and c times the constant, b times a c. Now to rewrite it so I can use the formula to solve for this particular example, I want to solve for k, so I'm going to divide everything by bc. And so I have the constant equaling a divided by bc. And so if I have 2 of them, I'm going to be using the formula of a1 divided by b1 c1 equals a2 divided by b2 c2. So now let's look at this. So we need to find a1 when b1 is -4 and c1 is -5, when a2 is -135, b2 is 5, and c2 is -9. So let's plug our numbers in. So a1, I need to find a when b1 is -4 times our c1, which is -5, equaling our a2, which is a -135, all over our b2, which is 5, times our c2, which is -9. And then just like I did the last example, I'm going to cross multiply and divide. So if I cross multiply here, that's going to give me a -45a equaling, on the other side, I'm going to have a -135 times a +20, which gives us a -2,700. To get a by itself, I'm going to divide everything by -45. And -2,700 divided by -45 will give us an a of 60. Now, if I were to put this back into this original equation right here, so if a is 60, I can now find the constant, or I can use this one to find the constant. So if I did 60 divided by BC, which BC was 20, they're saying the constant is 3. So if I were to do that, use this equation right here, A is 60. If I take 3 times my B, which is -4, times my C, which is -5, I still get 60 there. And if I did that with the other numbers, if I did A2 was -135, equaling the constant of 3 times my BC, which is 5, times -9. I would have 3 times 5 times -9, which gives me a -135. So here our A is going to be 60. In our last example, we're going to look at combined variation. Combined variation uses a combination of direct, inverse, and or joint variation. So in this example, I have direct variation and I have inverse variation. So it says suppose H, so I'm going to write H, varies directly. That means I take my constant times my F, and it says H varies inversely. That means I'm going to be dividing the K by the G. So that is my formula right now that I start off with based on what they're telling me. Now I need to rewrite this so I'm solving for the constant. So to get the K by itself, I'm going to be multiplying everything on the right side and the left side by the reciprocal. So it would be G over F. These cancel off and I'm left with K over here. That means I have to multiply this side by G over F. So I'm going to have the constant equals GH divided by F. This should have been an F right here. So now I'm going to have G1 H1 over F1 equals G2 H2 over F2. So now I need to find F1 when H1 is negative 12.6 and G1 is negative 10. If F2 is 20, H2 is 4, and G2 is 15. So let's substitute our numbers in for our variables. So I have G1, which is negative 10, times H1, which is negative 12.6. All that is divided by our F1, which we need to find. So I'll put F there. This has to equal our G2. Our G2 is 15. Our H2 is 4. And our F2 is 20. From this point, we're just going to cross multiply. So F times 15 times 4, and 15 times 4 is 60. So I have 60F equaling, and on the other side, I'm going to cross multiply. So I have negative 10 times negative 12.6 times 20, and that gives us 2,520. To get F by itself, I'm going to divide by 60, divide everything by 60, and I get F is going to equal 42. So that is how you can use the different formulas to find variation problems.